first lesson is from triangles. The exercise 6.2 from your NCERT textbook. So the first question is, in the following figure, here a figure is given. Here there are two conditions. The first condition is LM is parallel to CB and LN is parallel to CD. So these two conditions given for you. You have to prove that AM by AB is equal to AN by AD, which means AM by AB is equal to AN by AD. You have to prove this. So you have to use these two conditions which are given and prove this equation. So let us proceed to the solution. So we write in the given figure and draw the figure in the side. Here we use the first condition. LM is parallel to CB. So we use the basic proportionality theorem which we have got in the chapter of triangles. So what does the basic proportionality theorem say? In the theorem it says that a line intersecting two sides of a triangle, if that line is parallel to the third side, then that line divides two sides the same ratio. So here in this triangle ABC, you have LM intersecting AB and AC. Now it is given that LM is parallel to CB in condition. So by using that basic proportionality theorem, we have AM by AB. AM by AB is equal to AL by AC. We mark this as equation number 1. Similarly, there is another equation which is given as LN is parallel to CD. Now we use the basic proportionality theorem similarly for this condition. LN is parallel to CD. So basic proportionality theorem says that if LN is parallel to CD, then AN by AD is equal to AL by AC. We write this as equation number 2. Now you see in equation number 1 and equation number 2, there is one thing common. That common thing is AL by AC and AL by AC. That means the right side of both these equations are same. If in two conditions the right side of the two equations are same, that means the left hand part will also be same. So now by using number 1 and 2, we have AM by AB is equal to AN by AD. AM AB is equal to AN by AD. So we write this condition. That means we have found what we have to prove. AM by AB is equal to AN by AD. We have got this condition. So hence your equation is solved and the condition which you had required to prove has been proved, hence proved. So let us proceed to the next question of this lesson. In this question you have two triangles, one outside and one inside. There you have 3 points A, B and C. In this triangle, A, B and C are points on OP, OQ and OR. So these 3 points are on these lines. Now also two conditions are given. Those conditions are AM is parallel to PQ, AB is parallel to PQ and AC is parallel to PR. So these two conditions are given. You have to show that BC is parallel to QR. So this BC is parallel to QR. You have to show that. Now let us go to the solution. In the given figure, We first use this condition, AB is parallel to PQ. Now similarly to the last question, we use basic proportionality theorem. So by using basic proportionality theorem, what we have, if AB is parallel to PQ, then OA by AP is equal to OB by BQ. We use basic proportionality theorem to obtain this condition. We mark this as equation number 1. Now, similarly, another condition is given. AC is parallel to PR. AC is parallel to PR. Similarly, using basic proportionality theorem, what we have? We have OA by AP. OA by AP is equal to OC by CR. We write this as 2. Now, in equation number 1 and equation number 2, you have two things common, OA by AP and OA by AP. That means the left part of these two equations are same. If the left part of these two equations are same, then the right part will also be equal. So by using equation number 1 and equation number 2, we obtain OB by BQ is equal to OC by CR. So we have got this condition. Now see OB by BQ and OC by CR. OB by BQ and OC by CR. These two conditions are from the same triangle. Now similar to basic proportionality theorem, we have another converse of basic proportionality theorem. Now, what that converse of basic proportionality theorem states? It states that if in a triangle, a line intersects two sides such that the two sides are divided in the same ratio, then that line which is intersecting the two sides is parallel to the third side. So here, by using these two conditions, OB by BQ is equal to OC by CR, and using converse of basic proportional theorem, we obtain BC is parallel to QR. So we use converse of basic proportional theorem and get this BC is parallel to QR, which is exactly what you have to find a given question. So we have got this answer, hence proved. I hope you like this question. Let us proceed to the third question of this lesson. So the third question we have, here is a triangle ABC. AD is a line. So it is given that D is a point on the side BC of this triangle ABC, such that a condition is given. The condition is angle ADC. ADC, this angle is equal to BAC. BAC, this bigger angle. So these two angles are given equal. You have to show that CA square is equal to, see, CA square is equal to CB into CD. CB into CD. So this is a very simple question. So let us proceed to the solution. See, in this figure, there are two triangles. One triangle is ADC and another triangle is BAC. So we take those two triangles. In those two triangles, we have two conditions. One is the given condition, which is angle ADC is equal to angle BAC, which is already given. That means this angle, angle ADC is equal to angle BAC. Another angle which is equal is angle ACDC, this angle ACD and ACB. This angle is common for both the triangles. So we put this equation. So using these two conditions and using AA similarity, what does AA similarity says? If in two triangles, two angles are equal, then those two triangles are similar by AA criterion. So here two angles are equal, then by AA similarity we have angle ADC is similar to angle BAC. We have these two triangles similar. Now, since the two triangles are similar, what can we say about the two sides? The sides of both the triangles will be in the same ratio. So since triangle ADC and BAC are similar, we have AC by BC. That means the corresponding sides will be in the same ratio. So we put AC from this triangle and BC from the other triangle is equal to DC by AC. We need only two sides. Now we cross multiply AC into AC. What we get? AC square and BC into DC. AC square is equal to BC into DC. Now we just write AC as CA, BC as CB, and DC as CD. Why? Because question you have CA square, CB into CD. This is exactly what we have got. Just for the convenience of looking good, we have written AC as CA as in the question, BC as CB, and DC as CD, which is exactly what you have to find in the given. So we have found it by using AA similarity of these two triangles and using the corresponding sides as the same ratio. Hence, your answer is proof. I hope you have liked this lesson.